Alright boys, a couple little updates here. First, in case you didn't know, the blog page of arparobot.com, I'm actually um, like blogging on. I'm actually using it now, and I have a couple updates on that. A couple updates that I haven't covered yet. So, first one is this drawing is of a 2430 motor and a bunch of thumbtacks around it. And each thumbtack has a bunch of little pulley discs that will all rotate on it because I put a little metal sleeve around the thumbtacks called a fishing crimp sleeve, number 2 size. Um, and you can actually see that here. So here's a thumbtack, and you can see the little crimp sleeve on it. It's a pretty good fit. This is a stainless steel thumbtack, little fishing crimp sleeve, number 2. And here's a drawing of what it's going to be like, a close-up of the thumbtack with the crimp sleeve and then the little pulleys on it. And so basically you'll get 2-to-1 down gearing if the distance from here to here and here to here is about 2-to-1. And it also has forward and reverse directions. So one will enter and go clockwise, one will enter and go counterclockwise, and then the two smaller ones will be down geared, and one will go counterclockwise, one will go clockwise. And so you'll have forward and reverse down gearing all in one pulley, and causing both to become 2-to-1. And so by doing that a bunch of times, you're getting 2x, 2x, 2x the previous gearing. So this would be the stock gearing off the main shaft of the motor. This first pulley will 2x whatever that was, and then this will 2x the result. So it'd be 2x, 4x, 4 times 2 is 8x, 8 times 2 is 16x, 16 times 2 is 32x, 32 times 2 is 64x. The 64x will then flow into TPFE tubing and go down the side of the robot to wherever joint this motor is supposed to be actuating, which can be physically located significant distances away from the motor because we're translating this rotational force into pulling force by way of fishing line that we can then guide in our tubing. So this is 64-to-1 down gearing, all mounted within the overall size of the motor. And so it fits in the motor's existing form factor. Whereas like a typical down gearing would be some huge gearbox, which would be way bigger than this. So it's a very downscaled one. And I believe it should work, but we have to test it to see if we can actually make this in practice. But you can see I've already begun with a nice size thing here and a nice size tack. We'll just have to weld them all together and then pin them down onto the motor, probably sew them down into the cloth sleeve of the motor using suturing techniques and go from there. So I'm excited about that. And then the second thing I wanted to point out is for the dyno robot, where we are going to be using metal gear down gearing gearboxes. Unlike most of my other robots where I don't want to do that, the dyno robot we're just doing it quick and dirty. So we are going to be having a noisy robot for the dyno robot. And so to do that, we're going to be using a lot of N20 motors for like the fingers and stuff. But if we wanted to try to down gear a 2430 motor with metal gears, I thought, hey, why don't we use this nice little gearbox on this N20 motor that only costs 80 cents and it's 66 RPM gearbox. Why don't we use 4 of those per 2430 motor? Each one of these can handle about 5 or 6 pounds of stresses on it. And so if you have 4 of them on here, it can handle about 24-pound load capacity if you factor around 6 pounds per gear set distributed evenly. And so basically you would cut away the motor, revealing just the center shaft on the bottom. You'd keep the same output shaft, same gearing, wouldn't affect any of that. You just cut the motor off. You cut a slit down it, peel it all off, and just leave the center shaft. And then you cut the center shaft and top shaft down and add a pulley to each one. I just drew a really rough pulley here. And then these input pulleys on the bottom would connect to the center shaft of the motor. And so as the motor turns, these input shafts would turn. Now you would want to have two sets of pulleys in order to have reverse direction capability. So, and that's what we'd definitely do. So you'd have two sets of pulleys here and two sets of pulleys here. When the motor turns one way, it causes the entire gear set to turn that way. When the motor switches directions, the entire gear shaft switches directions. So you need two strings going to each bottom and two coming up each top. But I simplified it in this drawing, just showing a single direction setup. You just had another set and reverse the winding direction to be able to have it go both ways. And so anyways, you could mount all of these onto the form factor of the motor, just like the 60-40-1 example. This would give you 150 to 1 down gearing, but the trade-off is it's louder than the pulley idea, which was right here. It would be louder than this, but still, I think this is a reasonable option worth testing. So it's something I plan to test on the dyno robot potentially. Basically, it's too hard to turn down these cheap gears because they're only 80 cents per N20 motor. So if you can grab 4 gearboxes off it and use them together, you're basically getting $3.20 for an entire down gearing setup for a 2430 motor. Whereas if you were to buy like a cycloidal or planetary gear down gearing, you'd probably get like 30 to 1 down gearing for that. I'm not sure if they have different options beyond that, but that would cost you like $15 to $30, I think it said, and it'd be like this big. It'd be huge compared to this. So you'd be eating up your precious space very quickly. And so I think this is a nice downscaled way to do it that could be viable. And you can also squeeze these anywhere. It doesn't have to be right next to the motor shaft. You can put it anywhere and just run the string over to them and have it down here wherever you put them. So if you could find nooks and crannies that stick these things in where they'll fit, that's a possibility as well. So I just wanted to publish this idea, and this is something I may be experimenting with for the dyno robot.